1.8. Learners investigate the relationship between the current and the potential difference at a constant temperature. This all sounding a bit like Ohm's law, doesn't it? For three different resistors, X, Y, and Z. They obtain the graphs as shown. Now here is current plotted on this axis. There is potential difference on that axis. And here are three graphs where the slope of the graph is going to be proportional to R, or it's going to give me the value of R. The resistances of X, Y, and Z are Rx, Ry, and Rz, respectively. Which one of the following conclusions regarding the resistances of the resistors is correct? Now, if we have for a certain, now what I'm going to do here is just to try and analyze this a little bit and get ahead of what I'm going to be asked. If I take for a certain potential, difference across these resistors, Z gives me a lower current, Y a slightly higher current than that, and X gives me the highest current. That seems to suggest to me that if I put a potential across each of these resistors and I measure the currents, because X gives me the largest current, therefore this R is the lowest. And Z, R is the highest. RZ and Rx is the highest of those three, and Y sits somewhere in between. So if I'm comparing these things, Rx is the lowest, so it is less than Y, so it is less. Rx is less than Y, and Ry is less than Z. They are certainly not equal. Rx is definitely not greater. Rx is greater than Y, and Ry less than Z. So that's wrong as well. So my answer is definitely A.